Hello, how to solve 3 power t minus 2 power t, and this equals 65. You have 3 to the power of t. Then we can easily raise this to the power of 1, which is the same thing as t. T times 1 is t. Minus 2 power t, you raise it to the power of 1 again. And this equals 65. Now what we can do is to consider this idea of equivalent fractions. If you have 2 divided by 2, this is just like writing 1. So I'm going to replace this one with 2 divided by 2 and replace this one here with 2 divided by 2. So I have 3 to the power of t raised to the power of 2 over 2 minus 2 to the power of t raised to the power of 2 over 2. And this equals 65. So from here, I can multiply this out. I'm simply going to have 3 power 2t divided by 2 minus 2 power 2t divided by 2 equals 65. Now I can easily factor out t over 2. I can remember, if you have 2 or 2t over 2, this is just like writing 2 times t over 2. So if you have 3 times 3 power 2 times t over 2 minus 2 power 2 times t over 2, this equals 65. Remember, if you have a power n times n, this equals a power n to the power of n, and also equals a power n to the power of n. So we apply that here and here. You're going to have 3 to the power of t over 2 to the power of 2 minus 2 power t over 2 to the power of 2, and this equals 65. Now, at this particular point, we can say let x equals 3 power t over 2 and y equals 2 power t over 2. So this will give us x power 2 minus y power 2, and this equals 65. So from here, this becomes difference of 2 squares. We easily have x minus y times x plus y, and this equals 65. So this is product of 2 different numbers. That means we are going to split the 65 into 2 parts. 65 is simply 13 times 5, or we also have 5 times 13. So which of these combinations are we going to use? Now this is what we are going to do. Remember, this is minus, this is plus. So the sum will be greater than the minus. So that means this one that has the sum will go with the bigger number, which is 13, while the one that has the negative will go with the smaller number, that is 5. Do you understand? So that means we are going to have, we will equate each of these. We have x minus y equals 5, which is the smaller number because it is minus. We have x plus y equals 13, which is the 13 here because it's a greater number. Now we have these systems of equation. We can solve it. Let's solve for x. We can easily move this over here. This is our equation 1. This is equation 2. If we move this over here, we have x equals 5 plus y. This becomes equation 3. We are going to substitute this for x right here. So we have 5 plus y. This is for x here. Plus y equals 13 because there is plus y here. So from here, we have 5 plus 2y equals 13. Move 5 over here. We have 2y equals 13 minus 5. From here, we have 2y equals 13 minus 5 is simply, you are going to have 8. So you can easily solve for y. Divide this by 2. Divide this by 2. 2 cancels 2. We have y equals 4. Now, let's also solve for x by making use of this particular equation. We have x equals 5 plus y. Now y equals 4. We have x equals 5 plus 4. That means x equals 9. So right now, we have x equals 9 and y equals 4. All right, so what we are going to do is to recall the expression. Remember, now we have x equals 9, y equals 4. And what is our x? X equals 3 to the power of t over 2. And y equals 2 to the power of t over 2, right? That was what we did here. So to solve for t, we can either make use of x or make use of y. We can use any of them, but we are going to use the both of them in this video. Let's start with x. So we are going to have 3 power t over 2 equals 9. Now this is a perfect square. We can have 3 power t over 2 equals 9 is 3 power 2. Remember, if the bases are the same, you compare the exponents. For instance, you have a power b equals a power c, you have b equals c when the bases are the same. So you have t over 2 equals 2 is over 1. You cross multiply 1 times t, you have t equals 2 times 2, you have 4. So t equals 4 right here. Now let's also solve for t using y. Y equals 2 to the power of t over 2. So, and our y is 4. We have 4 equals 2 power t over 2. 4 is a perfect square, which is 2 power 2 equals 2 power t over 2. The same thing, when the bases are the same, you compare the exponents. You have 2 equals t over 2 is over 1. You cross multiply t times 1, that is t equals 2 times 2. You have 4. So in any of the cases, you have t equals 4. So that shows that our answer for t is 4. The next thing you can do is to insert the value here by checking. You have t equals 4. And you have 3 power 4 minus 2 power 4 is it 65? 3 power 4 is 3 times 3 times 3 times 3, that is 81 minus 2 power 4 is 2 times 2 times 2 times 2, that is 16. Is it the same thing as 65? That's what we are going to do. Now, 81 minus 16 is what? 81, 16. So you take 1 here and add 11 minus 6, that is 5. What do you have left here is 7, 7 minus 1, that is 6. So this is giving us 65, which equals 65 here. So that shows that our answer is absolutely correct, ladies and gentlemen. So this is it. And the most important thing for you to notice is how we were able to manipulate this by purposely raising this to the power of 1 and 1 here. Then we replace it with its equivalent fraction so that we can have difference of 2 squares. The major reason we did this was for us to make use of difference of 2 squares, because now that we have 2 divided by 2 here, We have 2 divided by 2 here. We factor out 2, then we can make use of difference of 2 squares, which actually resulted to this, in which we have 2 at the exponents. Then we apply the concept of difference of 2 squares, and we also divided this 65 into 2 parts. 2 numbers that will give us 65, which actually were 13 and 5. Then the bigger one, which has positive, is for 13, while the one that has negative is for 5. Then we equated each of them and solved for x and y. Then we inserted this back again and solved for t. That's just the summary of how we did everything. So don't forget to subscribe and share this video. Thank you and goodbye.